recapitulate the next unit of our chemistry, that is solutions. So let's begin with the solutions. Basically, what are the solutions? Solution is a homogeneous mixture of two or more pure substances, the relative ratio of which can be changed within a certain limits. Like when the constituents of the solution are 2, it is going to called as a binary. When the 3 constituents are there, it is called as a tertiary. In the case of 4, quaternary, and it goes on over. The two constituents of the solution are solvent and solute. Solvent. When we talk about the solvent, what is the solvent? Solvent is basically the component of the solution which is present in the relatively large proportion in the solution and whose physical state is same as that of the resulting solution. But when we talk about the component B, that is your solute. It is the component of a solution which is present in relatively small proportion. Now, on the basis of this, we can have the different types of the solution, and different types of solutions are the basically 3 types of the solution. The first is a gaseous solution. Then we have the liquid solution. Then we have the solid solution. Now, when we talk about the gaseous solution, in the case of the gaseous solution, we can have the solute, either gas, liquid, or the solid. At the same time, we can have the solvent, that is the gas in all 3 cases. For example, when we are talking about the gaseous solution, mixture of oxygen and nitrogen gas. Talking about the liquid gas, it will be chloroform mixed with nitrogen gas. Solid gas, camphor in the nitrogen gas. Second, the liquid solutions. Liquid solution के केस में solute can be your gas, liquid, and the solid. And your solvent will be liquid in all 3 cases. Now, if we look the example, your oxygen gas dissolved in the water, liquid, ethanol dissolved in a water, solid liquid, glucose dissolved in the water, or any of the example you can take. Third type of the solution, we have the solid. In the case of solid, again, we can have the solutes, gas, liquid, and solid. Your solvent in all 3 cases will remain as the solid only. For example, solution of hydrogen in palladium, liquid solid, amalgam of mercury with sodium, solid copper dissolved in gold. So these are the different types of the solution which we have done. Now basically when we talk about the solid liquid solutions, means in total how many we have done? We have done the 9 types. Among the 9 types, for us only the 3 are important which we are going to study. That is your solid liquid solutions, liquid solutions, and the gas liquid solution. Solid liquid solution, when we talk, it is in this a small amount of solute, usually we say the ionic solids, is dissolved in a large quantity of solvent. If the amount of solvent is large as compared to the solute, the solution is referred to as the dilute solution. Now, in this we say next terminology comes, that is the saturated solution. Saturated solution, we say that a solution is said to be saturated if it is holding the maximum amount of solute at a given temperature in a given quantity of the solvent. Means आपके पास एक set temperature है, set amount of solvent है, उसमें जितना ज़्यादा solute जो है वो dissolve हो सकता है, that is called as a saturated solution. On the basis of this, we define a solubility. Solubility is defined as the maximum amount of solute which can be dissolved in 100 gram of solvent at a specific temperature. The solubility of solute in liquid depends upon the three factors, that is your nature of solute, nature of solvent, and the temperature. Now, what are the causes of solubility? In the case of this, we have the different forces of attraction which takes place when a solute is mixed with the solvent. The first one is your interionic attraction. Interionic attraction in the solute molecules. Now, in this, we say that ions are held together in the lattice due to the electrostatic force. Due to these forces, what happens is molecules get stabilized and energy gets released. The energy which is going to release over here, it is called as a lattice energy. Second cause is the intermolecular attraction between solvent molecules. Now in this, we say that water is a polar solvent. Why? Because of the difference in the electronegativity between the hydrogen atom and the oxygen atom. Now this difference, because of this difference, there is a rise, or you can say development of a slight negative charge on the oxygen and positive charge on the hydrogen. Therefore, we say the dipole is being created. Therefore, we say that dipole-dipole attraction is present between the water molecules. Third cause is the solvation. Now, solvation, it represents the force of attraction between the solute and solvent molecules. If the solvent is water, then the energy released is going to be called as a hydration energy. Now, if your hydration energy is more than the lattice energy, then solution is easily formed. Both the ions of solute get hydrated to overcome the lattice energy of the solute. Fourth factor is the temperature. Saturated solutions represent equilibrium when dissolved solute and dissolved when undissolved solute and dissolved solute. Means कि delta solution H, if it is less than 0, means negative, then dissolution is going to be exothermic. And if your delta H is going to be bigger than the 0, then it is going to be the endothermic dissolution. Second, liquid-liquid solutions. Liquid-liquid solution means when you are mixing the two liquids, then three different situation arises. First is a miscible liquid. Miscible liquid means they are going to be completely solubilized with each other. Then partially miscible liquids. Partially miscible liquids occurs when the intermolecular forces of one liquid is greater than the other. However, this we can solubility we can increase in such cases by increasing the temperature. And third type the condition over here is the immiscible liquids, means two components are completely immiscible with each other. It occurs when one liquid is polar and another one is a non-polar. Third type of the solution, we have the gas liquid. In the case of gas liquid, these are generally soluble to a limited extent in other solvents. Now, solubility in this case depends on what? First, nature of gas. It depends on the nature of the gas. Means easily liquefiable gases are generally more soluble in the common solvents. Then nature of liquids. Now, those gases which easily form ions in solution are more soluble in water than in other solvents. Then pressure. Pressure is an important factor affecting the solubility of gas in liquids. Then temperature. That is, with rise in temperature, solubility generally decreases. Reason being is what? Because यहाँ पे gas is expelled. On the basis of this all, we study further the Henry's law, which is important according to the question. Henry law states that at a constant temperature, solubility of a gas in a liquid is directly proportional to the pressure of a gas. Equation we look, where Kh is the Henry's constant, X is the mole fraction of the gas, and P is the partial pressure. Now, what are the limitations of this Henry's law? Limitations of Henry's law is what? The pressure of the gas is not too high and temperature is not too low. The gas should not undergo any chemical change. The gas should not undergo association or dissociation in the solution. Where we can apply or the application of Henry's law? To increase the solubility of carbon dioxide in soda water, or you can say soft drinks, the bottle is sealed under the pressure, high pressure. To avoid the toxic effects of high concentration of nitrogen in the blood, the tanks which are used by the scuba divers, they are filled with the air diluted with the helium. Means जो scuba divers अपने साथ cylinders लेके जाते हैं, there is the presence of the helium, nitrogen and the oxygen. Then at high altitudes, low blood oxygen causes climbers to become weak and make them unable to think clearly, which are symptoms of a condition known as anoxia. On all these bases, we have the different formulas which we have already done in the grade 11. That is your mass percentage, volume percentage, parts per million, mole fraction, molarity and molality. Now, further, the important according to the question, we have the Raoult's law. Raoult's law as a special case, you can say, of a Henry's law it is. Raoult's law for a solution of volatile liquid, it states that a solution of volatile liquid, the partial pressure of each component of the solution is directly proportional to its mole fraction present in the solution. Means, आपका ये partial pressure है for the component A, it is going to be directly proportional to the mole fraction for the A. That states your Raoult's law. Now, on the basis of this, we can have the two type of solution, that is your ideal solution and a non-ideal solution. Ideal solution. When we talk about the ideal solutions are the solutions which obeys the Raoult's law, and non-ideal solutions are what? They are going to be solutions which are not going to obey the Raoult's law. Now, Raoult's law जो obey करेंगे, it means for the ideal solution, if I take out the total pressure, then what it is going to become? For component A, component B, from the previously derived, I'm not making it so much detail as we have already done this. Now, for example, your mixture of methanol, ethanol, N-hexane, N-heptane, benzene, toluene, they all are going to obey the Raoult's law. Now, reasons, what are the reasons behind for the formation of ideal solution? If your force of attraction between the molecules, अब दो molecules हैं आपके A and B, अगर उनके बीच में force of attraction जो है between the molecules, it comes out to be what? The force of attraction between the molecules is becomes like this. For example, this, it is equal. Then solution of A and B liquids will be ideal अगर A और B क्या similar structure है, similar polarity है. Then Raoult law is obeyed if your this condition is equal in both the cases. Then if your delta H is going to be 0 and delta V is going to be 0, then also they are going to obey the Raoult's law. Then Non-ideal solutions. They do not obey the Rawls law. For non-ideal solution, we say that delta H can never be zero, delta V can never be zero. Rawls law not obeying means it is not equal over here. Now, in the case of non-ideal solution, we can have the two types of the deviation. One deviation is a positive deviation and another is a negative deviation. पॉजिटिव डेविएशन हम कब बोलेंगे? जब पार्शियल प्रेशर हर एक कंपोनेंट का और रिजल्टेंट टोटल प्रेशर is going to be greater than the pressure which is on the basis of the Rawls law. Negative deviation we say when partial pressure हर एक component का और resultant total vapor pressure is going to be less than the pressure expected on the basis of the Rawls law. Next terminology which we have over here is the azeotropic mixture, which we also called as a azeotropes. Azeotropes are basically the binary mixtures which have the same composition in the liquid and the vapor phase, and they boil at a constant temperature. Now, types of the azeotropes are what? Minimum boiling azeotropes and maximum boiling azeotropes. मिनिमम बॉइलिंग एजियोट्रॉप्स बाइनरी मिक्सचर्स होते हैं जिनका बॉइलिंग पॉइंट इज लेस देन ईदर ऑफ द टू कंपोनेंट्स, और मैक्सिमम बॉइलिंग एजियोट्रॉप्स आर द बाइनरी मिक्सचर whose boiling point is more than either of the two components. After this, another important topic in this unit, we have the colligative properties. Colligative properties क्या हैं? These are the properties which depend on the number of solute particles. Number of solute particles means it can be molecules, it can be atoms, or it can be ions, but not upon the nature. Now, what are the colligative properties? It is relative lowering of vapor pressure of the solvent, elevation of boiling point of the solvent, depression of freezing point of the solvent, osmotic pressure of the solution. Now, in the case of relative lowering of vapor pressure, what happens over here? In this, we say when there is an addition of non-volatile solute to a volatile solvent, then decreases the escaping tendency of the solvent molecules from the surface of solution, जिसकी वजह से कुछ surface area is occupied by the non-volatile solute particles. Now, according to the Rawls law, what happens? जो relative lowering of the vapor pressure है, it becomes equal to the your mole fraction of the solute. The second one, your elevation of the boiling point. Elevation of the boiling point means what? Boiling point एक ऐसा temperature है जिस पे vapor pressure of liquid becomes equal to the atmospheric pressure. Up when you are having a non-volatile solute, your non-volatile solute is added to a volatile solvent, the vapor pressure of the solvent decreases. अब इस solution को जब आप boil करना चाहोगे तो its vapor pressure must be increased by raising the temperature above the boiling point of the pure solvent. अब जो यहाँ पे difference आएगा boiling point of the solution में और pure solvent के temperature में, that difference temperature is going to called as a elevation of boiling point. Okay. Next, depression of the freezing point. Freezing point क्या हो गया? It is a temperature जिस पे vapor pressure of a substance in its liquid phase is equal to its vapor pressure in the solid phase. अब solution freeze होगा in its when its vapor pressure is equal to the vapor pressure of the pure solid solvent. जब भी non volatile solute हो add करेंगे to the volatile solvent तो vapor pressure decrease हो जाएगा and it will become equal to that of solid solvent at lower temperature. इन दोनों के बीच के difference को we called as a depression of the freezing point. Now, among and your elevation of boiling point, we expect the numerical based questions over here. Then next property we have the osmosis. Osmosis is what? When a solution is separated from its solvent by a semi-permeable membrane, then there will be a spontaneous flow of solvent molecules from solvent compartment to a solution. Now what is इस phenomena को हम osmosis बोलते हैं. Semi-permeable membrane क्या हो गया? It is a membrane जिससे only solvent molecules can pass but solute molecules cannot pass. Living cells की wall, they all come under the category of the semi-permeable membrane. Next is your osmotic pressure. Osmotic pressure जो है solution का is the excess pressure that must be applied to a solution to prevent osmosis. Means basically एक ये ऐसा passage है to stop the passage of the solvent molecules into it through a semi-permeable membrane. Then we have the reverse osmosis. Reverse osmosis क्या हो गया? अगर pressure ज़्यादा है then the osmotic pressure applied to the solution side. तो pure solvent जो है वो flow करेगा out of the solution through the semi-permeable membrane. इसमें क्या हो जाएगा? जो direction होगा osmosis का, it is going to be reversed. Therefore, it is called as a reverse osmosis. On the all basis of this, we have the different types of the solutions: isotonic, isosmotic, hypertonic, and plasmolysis. With this, we finish the recapitulation of the solutions. Now, what type of questions we can expect? The very first important question which we can expect is the numerical based questions. The one of the most important part of this unit according to the question answer based is a numerical based only, and after that we can expect the give reason question. For example, that why is glycol and water mixture is used in the car radiators in the cold countries? What is a de-icing agent? What is an antifreeze? What is an antifreeze? What is the cryoscopic constant? इस टाइप के एक एक मार्क्स के क्वेश्चन besides the numerical problems we can expect, like cooking is faster in the pressure cooker than in the cooking pan. What is the reason? RBCs shrink when they are placed in the saline water but swell in the distilled water. So such type of the questions we expect from this part. Thank you for today.